Okay, let's look at this fertilizer question from November 2017. It says the equations below represent two industrial processes involved in the preparation of ammonium nitrate, process X and process Y. Well, process Y's got not much going on. Nitrogen plus hydrogen gives you ammonia, so this has to be the Haber process. Now look at this one. We've got oxygen and something giving us nitrogen monoxide, and then we're adding oxygen and we're ending up with nitric acid. So process X has to be the Ostwald process, yes? Okay, so let's look at the questions. What is the name of substance A? Well, what is the starter for the Ostwald process? It is ammonia. Okay, so you can't write the formula. It says what is the name. If you write the formula, you will not get the mark. Then it says to you, what is the formula of substance B? Well, what happens when you get nitrogen monoxide and you add oxygen? You get nitrogen dioxide, whose formula is NO2. If you write the name, you will get it wrong. You have to write the formula when it says formula. Then it says to you, what is the name given for reaction 1? So this is reaction 1. This reaction is when we react ammonia with oxygen. And we usually do it in the presence of a catalyst, so it's the oxidation of ammonia, but we're going to call it the catalytic oxidation of ammonia, because that's what it is when you learn it, like a parrot, from all the details that you've been given. And then, just like a parrot, you learned what was the catalyst used in reaction 1 in this catalytic oxidation of ammonia. It is platinum or PT, because this one either will be accepted because it says the name or the formula. Then it says what is the name of process X? That is the Ostwald process. What is the name of process Y? That is the Haber process. You have to learn these things and all of their reactions and reaction conditions. And then it says to you, what is the balanced equation for the preparation of ammonium nitrate from the products obtained? So have a look here, even if you don't know what's going on. Can you see here we're going to make a reaction using the products. So what are my two products here? You must just copy them down nicely here. It is ammonia, and my other product, we're not using the nitrogen monoxide, which I hope you know. The other product we're using is nitric acid, and so we go from ammonia and nitric acid to ammonium nitrate, and that equation is already balanced as it is. 1 mark for the reactants in front of the arrow, 1 mark for the product. So for instance, if you didn't know the formula for ammonium nitrate, if you just wrote NH3 plus HNO3, both of which we've just taken directly out of the question, okay, those two formulas plus a forward arrow should give you a mark for reactants. And then if you fluffed writing ammonium nitrate, you've still got at least 1 mark. Now it says to you, a 15 kilogram bag of fertilizer contains 5% phosphorus, 10% nitrogen, and 15% potassium. Calculate the mass of phosphorus in the bag. Now, I think a little grade 8 with a brain could work this out, because we have got 5% phosphorus. So 5% is 5 over 100. And what does the whole bag weigh? The whole bag weighs 15 kilos. So 5% of 15 kilos is, where is your calculator? 0.75 kilograms. It's as easy as that, and as you can see, it's only 2 marks. So then 10.2.2 says to you, what is the mass of filler in the bag? So basically, everything in the bag that is not a chemical compound is filler. So if we have a look here, we've got 5% plus 10% plus 15%. So that comes to 30%. So in my bag, 30% is the fertilizer chemicals. Okay. So how much filler is there? 100% minus 30% is 70%. That is how much filler I've got. So it is 70% of the total mass of the bag, which was 15 kilograms, and this is 10.5 kilograms. Whoopsie. 10.5 kilograms of filler. That was quite an easy question, but you must have memorized all of your fertilizer processes.